Well, as they say, there's nothing so simple as I can't screw it up, and this one is quite a stupid screw up. I got myself a wiring diagram, and I was just wiring up the limit switches, and as you can see, I've drawn on just regular switches powered by 24 volts. So, and I was thinking when I drew this of using the micro switches, but then I changed my mind and decided to go for inductive sensors, but I didn't update the diagram. So now that's not bad. That's not the worst of it, because of course what I've also done is just seen, well, two wires here, and I've also wired up the K, the machine halt sensor, or wires, and I've just wired it pins 1, 2, 3, 4. Well, that's completely wrong, because it should be wired into this relay coil instead. Well, of course, common and the normally open. So, and the actual socket, this socket here, well, the K is okay, it can stay where it is, but then the other 3 pins are going to need to be on the sensors. So the plus 24 volts, the load, and the 0 volts, and that will be in here somewhere. So the diagram's going to get a bit more complicated, but I don't know, I've just had a bit of a brain freeze, so I thought I'd best have a look at exactly how I'm going to wire these sensors. I'm going to do a dry run of it on them. So I've got the multimeter ready, and I've got a spare relay, and I've got a sensor, and I needed a power source. So got an old laptop that's, I don't know what's happened to the laptop, but this is rather convenient. Let's see if you can see that. No, probably can't. Anyway, this gives 19.5 volts DC. The relay is 24 volts, and these will do, can't remember, from 6 to 36 volts. So yeah, 19.5 volts is just about enough to close the relay, even though it's 24 volts. They're quite flexible. As you can see, I've already got it powered on, I've probed it, and yeah, it's bang on 19.5 volts. So now I'm just going to look for some way of getting power out of that more easily, because at the minute I'm a bit concerned that that pin in the middle there is an earth pin. I wouldn't have thought so, but I don't want to find out when everything goes bang. So I want to find something I can plug that into to run it across to a bit of chocky block to give me a 19.5 volt source, and then I'll wire the sensors in. I'll wire a sensor into the voltage and the relay, and I'll move metal towards the sensor and close the relay, and then I'll next step I'll wire a number of sensors in series, and to just check that I can touch any one of the sensors and close the relay. I'm part way through the fix now of converting the limits from micro switches over to inductive sensors. I've been away and updated the circuit diagram. This connector is a little bit, what I'm using are these little blue boxes to show where the connectors pins go. I know it's not standard for a circuit diagram, but it helps me. This connector is a bit complicated because it's actually spread across 3 points in the diagram, and this one in particular is confusing because it's switching the neutral on the coil. Most of the connectors are like this. They're quite simple. They're all in one place. I've also updated the DIN wiring diagram, although as soon as I got downstairs to the workshop I noticed I'd got those numbers back to front. What can you do? The cable, I've pulled the cable out. This was all wired up to the bob. These two wires are for the machine hold, so K to ground, and then these 3 wires are for the sensors. This earth wire. Let me see if I can get it. That earth wire is actually for the sheath. The earth wire in the cable has now been extended with a piece of black wire. You just see a little bit of the green and yellow there, and then the brown and the blue will be as they are for the sensors. So this will be the brown will be the 24 volts, the blue the 0, and then the black is the load wire. Without unsoldering it, I won't be able to get through to the socket, to the back of the socket, so I'll just leave that green and yellow. The only thing left to do now actually is extend the brown wire slightly, because that's got to, because of the way the cable lays, it's got to come back up the trunking a little bit to get to a 24 volt supply. But that's just a quick bit of soldering and we're done. There we go. The circuit's rewired correctly now. I won't get too close because it's all powered up. So from the 24 volt main block or distribution point, I've got the cable running around to that relay there. So that provides the positive side of the coil, and then you can see the negative coming out of there goes along this cable to pin 5 on here. I've just shoved those cables in for now, and then I've got a separate cable from there running to pin 1, and this block here is the 24 volt neutral block, or 0 volt, and that blue cable runs to pin 2. So if I just shove the connectors in here, then you can see the light comes on the sensor, and if I approach some metal, it goes off. Okay. I think that's focused. And if you look at the relay, there we go. Next step is to wire the output of the relay, or the other side of the relay, into the e-stop, because as you can see the e-stop at the minute is activated. It actually is going to be activated whatever, because I'm in a test mode on the PMDX and that always asserts e-stop, but I'll take it out of test mode and make sure the e-stop works. Here's a very quick demo of the e-stop circuit working, or the limit circuit working. As you can see down on the PMDX, I've switched it all to closed, which is run normal mode. That's probably the mode I'll be using, but for now that's good enough. Up the top left there, around here, is the e-stop LED. As you can see, it's off, which is deactivated, and my connector, my sensor, has the light on, and the relay is closed. And as I bring the sensor close to the case, the e-stop circuit is activated, and the machine in that case should then stop. There you go, proof of concept of the limits working.